We're going to graph our next equation here. We've got the cubed root of x minus 2. So it's the cubed root of x minus 2. We need to figure out where, like any DNEs and stuff like that, and cube root is defined everywhere, so we don't have to worry about that. If we're curious, x equals 2 will create a 0, so we know that the point 0, 2 is on the graph. Whoops, change my color here. So if I start my graph, 0, 2 is on my graph, and then we'll kind of go from there. So just like the other ones, I'm going to actually change some color. Well, no, I'll leave it as black and white. I need to find f prime to find the mins and maxes. So I'm going to think about this as being x minus 2 to the 1/3 power. Okay? Same thing. So when I take this derivative, it is 1/3 x minus 2 to the negative 2/3, because 1/3 minus 1 is negative 2/3. I am going to set this equal to 0, and I'm going to make a little note to myself, N, D, and E, right? Those are what I care about, zeros and D and E's. So I'm going to do this, and I'm going to turn this back into better algebraic notation. So x minus 2 to the 2/3 equals 0. Well, I know that I'm not allowed to divide by 0. So I know that this thing does not exist at x equals 2. Because if I plug in 2 here, 0 squared and then the cube root, it's all 0. 1 divided by 0, 0. That's my issue. I also know that this function will never equal 0 because the numerator will never equal 0 if I cross multiply it. So I've got this DNE at x equals 2, but I happen to know the point exists, just we can't calculate the slope at that point for some reason. We don't know why yet. But we'll do some more math to figure out maybe why we can't do that. So we're going to find our f double prime. And f double prime is the derivative of f prime. So this turns into negative 2/3 times 1/3 is negative 2/9. X minus 2 to the negative 2/3 minus 3/3 is negative 5/3. Okay, so I have the same exact question that I have to figure out is when is it 0 and D and E, or D and E I should say. I shouldn't have said and, or D and E. And I'm going to write it in good algebraic notation, and I'll put this in the denominator, x minus 2 to the 5/3, and we'll notice again, the numerator will never be 0, so we don't have to worry about zeros, but we do have to worry about D and E's. When x equals 2, we have a D and E, right? So that means we can't calculate the concavity there either, which totally makes sense. If you don't have f prime at somewhere, you definitely won't have f double prime at the same place. But those are our only things that we now know. And that makes our graphs nice, or our chart, I should say, our chart very nice, because we only care about the point 2. There it is. I get to find f prime to the left of 2. So that means I can plug in a number like 0. I'm going to plug 0 in for f prime. All right, so I'm going to show that math. I'm going to have 1/3 of 0 minus 2 to the negative 2/3. You've got to be really careful with this. I should have given myself a little bit more room. So I'm just going to work upward. We know that this is just negative 2 in here, so really I have 1/3 and then 2 to the 2/3 power, negative 2 to the 2/3 power. And notice, I'm going to take negative 2 and I'm going to square it. when I square negative 2, it becomes 4, positive 4. And then I take the cube root of a positive number, I'm going to get a positive number. It doesn't really matter what the number is, but that positive number times positive 3, 1 over that, it's still positive. So I know that this is going to be a positive slope. I also want to point out, anytime you have an even power up here, anytime you have an even power in the numerator for your exponent, the answer is going to be positive. So that makes our next calculation pretty easy. I'm going to plug in a number to the right of 2, like 3. If I plug in 3 here, 3 minus 2 is 1. Well, 1 to an even power is also going to be positive. So this is positive slope in both things. Now we have to do the same thing for our concavity. So I'm going to plug in a number down here for our concavity. I'm going to plug in 0 for the left side. Notice that it is a 5, not a 2, right? 5 is odd, so this is actually going to give me a negative answer times a negative, so it's actually going to give me a positive, all right? This is actually going to give me a positive. And I'm going to do that math so you can see it maybe a little bit clearer. So we have negative 2. I'm plugging in 0 over 9 times 0 minus 2, 5 thirds. I don't care about the value of negative 2 to the 5 thirds. What I care about is the fact that it is negative. So I have negative 2 divided by 9 times a negative number. Therefore, this is greater than 0. It's positive. That's all that matters. So that's why we have that shape. I need to plug in another number to the right of 2. I'm going to pick the number 3. So I'm going to really have 1 to the 5 thirds. That's going to give me a positive. 9 times a positive is positive. Negative 2 divided by a positive is negative. So I have this shape. All right. I'm going to put a little chart. Remember this chart that we have like this and like this. So when I have a positive slope and a positive concavity, a positive slope and a positive concavity, I have that shape. So I have to start here with this 2 and have that shape all the way out to infinity. I know at 2 itself, the slope doesn't exist. So then I need to do the same thing to the right of 2. So I have a positive slope and a negative concavity. A positive slope and a negative concavity looks like that. So I'm going to draw this line like this. So here's the interesting thing. The slope doesn't exist at 2 because the tangent line would be a vertical line. And so we'd end up with a vertical slope, and we always say, like, vertical lines, the slope doesn't exist. It's undefined, is what we probably said in Algebra 1. So there it is. Okay, that's the next one.